common difference, subtract a term from the specific term. Take a look at this example. 2, 8, 14, 20. Do you recognize the sequence? They have a common number. You have to add that number, then you will get the next term. 2 plus 6 is equals 8. 8 plus 6 is equals 14. 14 plus 6 is equals 20. What do you think is your common difference? Exactly. It's 6. Pretty easy, right? How about the terms of the arithmetic sequence? Terms of an arithmetic sequence. This sequence of numbers where the difference between consecutive terms is constant. This constant difference is called common difference, denoted as C. Here's the general form for arithmetic sequence. an equals a1 plus n minus 1, where an is the last term, a1 is the first term, d is the common difference, and n is the third number. Let's try to find the 21st term of this following sequence. This sequence is 4, 11, 18, 25. We write 8, 21 equals 4 because 4 is its first term. 21 minus 1, 21 meaning our number of terms, is equals to 4 plus 20 and 7. 7 being our common difference. We got 20 from 21 minus 1. Following 4 plus 140 is equals to 144. Did you learn something? Try to follow the sequence and try for yourself. Thank you for listening, and I hope you learned something.
Hi everyone, I'm Charlize Hoy, and today we're going to learn about geometric sequences. It's one of the important parts of math that shows up in everything from basic to finance. Let's get started. What is geometric sequence? A geometric sequence is a list of numbers where each term is found by multiplying the previous term by the same number. This number is called the common ratio. Let's take a look at an example. 2, 4, 8, 16, and 32. Can you tell what's happening? Each term is multiplied by 2 to get to the next one. So the common ratio here is 2. How to identify the common ratio? To find the common ratio, divide any term by the one before it. Let's take the same example. 8 divided by 4 equals 2. 4 divided by 2 equals 2. So R equals 2. If R is greater than 1, it goes. If R is between 0 and 1, it shrinks. And if R is negative, the terms alternate signs. We can find any term in geometric sequence using this formula. an equals a sub 1 times r n minus 1. An is the term you're looking for, a sub 1 is the first term, r is the common ratio, and n is the position of the term. Let's try it. If a sub 1 equals 8 and r equals 2, what's the fifth term? A sub 5 equals 3 times 4 to the power of 4 equals 3 times 16 equals 48. Geometric sequences are more than just numbers. They appear in compound interest, linear growth, population modeling, and even in computer graphics. Pretty cool, right? Here's a quick recap. A geometric sequence multiplies by the same number each time, and the common ratio r is 3. Use the formula an equals a sub 1 times r n minus 1 to find any term. And that's it. Now you know how to work with geometric sequences. Try making your own and see the pattern grow. That's all. Thank you so much for listening.
Good day everyone. My name is Basbas, and I'm here today to show you the Fibonacci sequence. What is the Fibonacci sequence? The Fibonacci sequence is a series of numbers where each term is the sum of the two previous terms. It starts like this. 0, 1, 1, 2, 3, 5, 8, 1, 34, so on. Let's break that down. The first number is 0. The second number is 1. And 0 plus 1 is equals 1, which is the third number. 1 plus 1 is equals to 2, which is the fourth number. 1 plus 2 is equals to 3. The fifth number. That's 2 plus 3 equals 5, which is the Mathematically, the Fibonacci sequence can be written using this formula. F n equals f n minus 1 plus f n minus 2. That just means to find the Fibonacci number, add the n1, n minus 1, and n minus 2 numbers. Example, if f5 is equals to 5 and f4 is equals to 3, then f6 is equals to 5 plus 3 equals 8. Well, let's try creating our own Fibonacci sequence. We will start with 0 and add 1. Then we will keep adding the last two numbers to get the next one. We have here the sequence 0, 1, 2, 3, 4. What is the ninth term in the sequence? That's right, it is 21. And that's a wrap on the Fibonacci sequence. To recap, it's a sequence where each term is the sum of the two before it. It starts with 0 and 1. And thus, it appears everywhere, from math problems to flowers and seashells. Thanks for watching.
My name is Rosa from Alejan, and I will be explaining what is harmonic sequence. It is a sequence of numbers where the reciprocals of the terms form an arithmetic sequence. So first we'll take reciprocals of each term. That means we will flip them. Here is an example. We have 1 over 3, 1 over 5, and 1 over 7. And we're going to be finding the ninth term. But before we do that, we need to convert it to an arithmetic sequence. We'll take the reciprocals of each term. That means we're going to flip them. So 1 over 3 becomes 3, 1 over 5 becomes 5, and 1 over 7 becomes 7. So in order to do that, we use the formula for the nth term of an arithmetic sequence, which is an equals a sub 1 plus n minus 1 times b. So our a sub 1 is going to be 1, our first term. And then the common difference is 2. And then the position of our term. Now let's plug in the values. So we have sub 9 equals 1 replacing a sub 1, 9 replacing the position of the term, which is n, and 2 replacing the common difference, which is p. We're going to be subtracting 9 by 1, that will result to 8. Now we're going to be multiplying 8 by 2, that will result to 16. We're going to add 1 to 16, that will result to 17. That will turn to 17 over 1. We're gonna be flipping it back to its harmonic form. It'll be 1 over 17, and that's how you get the final answer. And here's a quick recap. Take reciprocals and check for arithmetic pattern. The harmonic sequence is from an arithmetic 1. Use the formula 1 over a sub 1 plus n minus 1 times 2 to find the terms. That's all. Thank you for listening.